take a look at how a subsidy would affect a competitive market. A subsidy is like a reverse tax. In this situation, instead of the consumer or the producer paying something to the government's actually paying them for every unit that they produce or they consume. To analyze a subsidy, we're going to start by using what we call a subsidy wedge. The subsidy wedge is similar to a tax wedge in that you'll find a particular quantity where the difference between the demand and the supply curve is equal to the subsidy. The only difference here is, unlike a tax where the tax will reduce the equilibrium quantity of transactions, a subsidy will actually encourage more transactions. With the subsidy, it doesn't matter whether you give the subsidy to the seller or you give the subsidy to the consumer. The subsidy is going to lower the price that the seller actually pays. And you can see that off the demand curve. If consumers are going to purchase Q-star units, they will only do so if the price that the consumer pays is less than the original equilibrium price. So here's the price that the consumer or the buyer will pay. For the seller, again, it does not matter whether the subsidy is initially given to the buyer or the seller. For the seller, the subsidy is going to increase the price that they receive. Thus, that's why they're encouraged to produce more units with a subsidy than they were without. So in this case, with the subsidy, the producer is willing to produce Q-star units as long as they receive this price of PS. So the difference between the price that the seller receives and the price that the buyer pays is equal to the value of the subsidy, which we're assuming is $5 in this case. Now, just to emphasize that it does not matter whether the consumer or the producer receives the subsidy, let's imagine that the subsidy was initially given to the seller. If a $5 subsidy is given to the seller, then you can think of this as the subsidy is going to reduce the marginal cost of production. So the supply curve would shift down by the value of the subsidy. So that means that each and every quantity, the supply curve would shift down by $5. So at a quantity of Q0, it would shift down by $5. At a quantity of Q star, it would shift down by $5. And so you would get this new supply curve, and that new supply curve represents what the firm is willing and able to sell for with the subsidy. In this case, they're willing to sell to the buyer for a price as low as PB, knowing that once the buyer hands over that amount of money and the government kicks in the $5 subsidy, the firm will actually receive PS. Now, alternatively, we could say, well, what if that subsidy had been given to the buyer? If the subsidy had been given to the buyer, now when the buyer is out shopping, the buyer's willingness to pay will increase. Before, the maximum price that the buyer was willing to pay was right off the demand curve. But now, if they are going to receive a $5 subsidy for every unit that they purchase, the amount that they are willing to pay will be $5 higher than the demand curve. So at Q0, they're willing to pay $5 more. At Q star, they're willing to pay $5 more, and so on. At each and every quantity, they're willing and able to pay $5 more. So the subsidy will affect the amount that the consumer is willing to pay. They're willing to pay more for something than what it is worth to them. So they're willing to pay the seller this amount of money, but the actual out-of-pocket cost to the consumers is equal to PS less the $5 or PB. It doesn't matter whether it's the buyer who gets the subsidy or the seller that gets the subsidy, the outcome is the same. And so that's why, for simplicity, we will just be using the subsidy wedge.